Have you ever noticed a dripping faucet? That slow, steady drip might seem harmless, but over time, it can waste gallons of water and drive up your utility bill. Now, imagine that same drip, but instead of water, it's a valuable chemical or hazardous fluid leaking from an industrial pump. The stakes are much higher. Every drop lost can mean wasted resources, environmental harm, and even danger to workers. Even a small leak can quickly become a costly and dangerous problem. Lost product, safety hazards, and unplanned downtime. What starts as a minor issue can escalate, leading to equipment damage, regulatory fines, and expensive repairs. In industry, stopping leaks is about more than just saving money. It's about safety, efficiency, and responsibility to both people and the environment. Every leak prevented helps protect workers, reduce waste, and keep operations running smoothly. Pumps move fluids using a spinning shaft, but that shaft creates a gap, an escape route for leaks. This gap is necessary for the pump to function, but it's also a weak point where fluids can escape if not properly sealed. We need a way to seal the gap between the spinning shaft and the stationary pump housing. Without a reliable seal, leaks are inevitable, no matter how well the pump is built. This is where mechanical seals come in, a marvel of engineering that keeps fluids contained. These seals are designed to handle extreme pressures, temperatures, and corrosive chemicals, all while allowing the pump to operate efficiently. In this video, we'll explore why mechanical seals matter, how they work, and what makes them so effective. You'll see how these small components play a huge role in keeping industries safe and productive. We'll break down their parts, reveal the science behind their operation, and explain why a tiny, invisible leak is actually a good thing. Sometimes, a controlled leak is necessary to keep the seal lubricated and functioning properly. We'll also cover common reasons seals fail and share practical maintenance tips to keep your pumps running smoothly. Regular inspection and timely replacement can prevent major breakdowns and extend equipment life. By the end, you'll see that a mechanical seal is more than just metal and rubber. It's a key to modern industry. These unsung heroes are essential for everything from food processing to power generation. Ready to dive into the science of sealing? Let's get started and discover how stopping leaks can make a world of difference. Drip, drip, let's fix that, together. For many decades, pumps relied heavily on gland packing, rings of braided material that were carefully stuffed around the shaft and then compressed to form a seal. This method was widely used due to its simplicity and ruggedness. However, it creates significant friction, leading to wasted energy, and it always leaks a little to stay cool, which is not ideal. The packing can be quite messy and is far from ideal when dealing with hazardous or expensive fluids, as it can lead to contamination and loss. Enter the mechanical seal, a revolutionary design featuring two ultra-flat faces, one spinning, one stationary, pressed together by a spring and fluid pressure, creating a more effective seal. The sealing action occurs at a microscopic level, drastically reducing leakage and ensuring a more secure operation. Unlike traditional packing, a mechanical seal can operate with almost no visible leak, just a faint vapor, making it much cleaner. Less friction means less wear and tear on the components, leading to lower energy consumption and longer lifespan of the equipment. While mechanical seals are more complex and have a higher initial cost, their efficiency and reliability make them the standard choice in modern pumps, offering long-term savings. It's a significant leap from plugging a bottle with a cork to using a precision screw cap, symbolizing the advancement in sealing technology. Mechanical seals represent the future of leak prevention, showcasing how science and technology continue to advance and improve our industrial processes. Science marches on. Let's meet the main parts of a mechanical seal, the unsung heroes that keep pumps running smoothly and prevent leaks in countless machines. First up, the seal faces. There are two of them. One is rotary, spinning in perfect sync with the shaft, while the other remains stationary, firmly attached to the pump housing. Together they form the heart of the seal. These faces are polished to an almost mirror-like flatness and crafted from incredibly tough materials like carbon graphite or silicon carbide. This ensures they can withstand intense pressure and constant motion. Their job: to slide against each other with as little friction as possible, all while maintaining maximum durability. This delicate balance is what keeps the seal working efficiently for a long time. Next, we have the spring. Sometimes it's a single spring, other times multiple springs or even a flexible metal bellows. Its role is to push the faces together, ensuring they stay in contact even before the pump starts spinning. Without this gentle but constant force, the seal faces would separate, and the seal would fail almost instantly, allowing leaks to occur. Then come the secondary seals, like O-rings and gaskets. These flexible components prevent leaks along other paths, sealing the gaps between the faces and the pumper shaft, and blocking any potential escape routes for fluids. Every part has a specific purpose. The faces do the actual sealing. The spring keeps them pressed together, and the O-rings or gaskets stop any sneaky leaks from slipping by. It's a carefully engineered system. It's a precision system where every single component matters, and even the smallest part plays a crucial role in the seal's overall performance. The result? A reliable, long-lasting seal that keeps fluids exactly where they belong, protecting equipment and preventing costly downtime. That's teamwork in action. Now that you've met the key players, let's see how it all works together. On to the science. So, how do two flat faces seal high-pressure fluid without grinding themselves to dust? The secret is a microscopic film of fluid that forms between the faces when the pump runs. This film, just micrometers thick, lubricates and cools the faces, preventing wear and overheating. The spring and fluid pressure push the faces together, while the fluid film tries to separate them. A perfect balance. Too little film, and the faces overheat. Too much, and you get leaks. The result is a dynamic, self-correcting system that can run for thousands of hours. The fluid being pumped is both the thing being sealed and the lubricant that keeps the seal alive. It's elegant physics in action. That's the magic of mechanical seals. Here's a twist. A mechanical seal is designed to leak just a tiny bit. The lubricating film between the faces must escape somewhere, so a microscopic amount seeps out, often flashing to vapor. This controlled seepage is essential. Without it, the faces would run dry and fail in seconds. Think of it like engine oil. Without a film, moving parts would grind to a halt. A healthy seal leaves only a faint haze or residue, not a puddle. If you see absolutely no sign of leakage, the seal might be running dry. A warning sign. That tiny leak is proof the seal is working as designed. In sealing, a little leak is a good thing. Appreciate the science at work. Sometimes, a basic seal isn't enough. For high pressures, a balanced seal reduces the force on the faces, protecting the lubricating film and extending seal life. For hazardous or abrasive fluids, dual seals use two sets of faces with a buffer or barrier fluid in between, boosting safety and reliability. Buffer fluid arrangements let process fluid leak in. Barrier fluid setups keep only clean fluid leaking out. For easy installation, cartridge seals come pre-assembled. Just slide them in, tighten, and you're done. Cartridge designs reduce installation errors and speed up maintenance. Each upgrade, balanced, dual, or cartridge, solves a specific challenge. The right seal design means longer life and safer operation. Choose wisely for your application. That's smart engineering. Let's keep going. Even the best seals can fail. Here's how to prevent it. Dry running is the top killer. Always make sure the pump is primed and full before starting. Abrasive particles like sand can scratch the faces. Use filters, flush plans, or harder materials to protect the seal. Shock and vibration from misalignment or bad bearings can chip the faces. Keep your system well maintained and aligned. Chemical attack happens if the seal materials aren't compatible with the fluid. Always check compatibility before installation. Prevention is about clean fluids, correct materials, and careful system maintenance. Regular checks and good housekeeping go a long way. A smooth-running pump means a happy seal. Know your enemy, and you'll keep leaks at bay. Let's wrap up with some key tips. On to maintenance. Stay ahead of failures. Installation and maintenance are just as important as the seal itself. Cleanliness is critical. Dirt or rust can ruin a new seal before it even starts. Lubricate O-rings before installation, and never handle seal faces with bare hands. Keep process fluid as clean as possible. Use separators or filters if needed. Regularly check for leaks, noise, or heat near the seal gland. These are early warning signs. Never run a pump dry. Always ensure there's liquid for the lubricating film. Install seals carefully. Precision matters. Quick, regular checks can prevent catastrophic failures. Respect the lubricating film. It's the secret to long seal life. A well-installed, well-maintained seal keeps pumps running efficiently and safely. Remember, clean, careful, and consistent is the recipe for success. Master the science and your pumps will thank you. Thanks for watching. Seal the deal.